I'd like to introduce you to Nimish Biloria, and that's a very, very great pleasure for me because Nimish came to Sydney 1.5 years ago, more or less, half a year after I arrived. We worked very close together, and we both enjoyed it a lot. And then you organized a conference that is called Smart and Sustainable Built Environments. And everyone talks about sustainability. You finally want to meet someone who's talking about smart cities, isn't he? So, well, there he is. He used to work in Delft, University of Technology, in a hyperbody center, call it like that. And interesting enough, he shifted more or less his thinking from the build and material level to the urban level. And I think that's really an interesting application of your thinking. And you're going to tell us more about it. I'm looking forward to it. Enjoy.
So, yeah, first I need to lower this because I'm not Dutch. So. But yeah, thanks Rob, wonderful to again sort of be speaking here. And also it's great to see Andy, who was apparently my boss also at there. So, hi. So, well, actually the title of today's lecture I thought could be something which is a mix basically of both. I'm looking at smart and livable cities, but essentially trying to understand this intricate linkage between people, space, technology and economics. And basically how each and every one of these characteristics basically have something to offer to the other. I also put this video deliberately behind it because it's also a bit of an example of not necessarily zooming into the city scale immediately, but actually starting to look at small object-based entities and how they can create a difference. For just a simple example, in this case, basically the movements that you see in this particular object is connected with physiologically sensed data, basically at this amount of stress levels that a person is actually exhibiting, which is actually connected with an actuating system, which is actually trying to compress space within which the person actually sits and meditates. So the idea of actually working with my own data, my human self, connecting myself with the spatial characteristics of this, which is then connected with computational systems, which are then trying to drive and basically calm myself down. Interestingly, basically, I started experimenting with these also because of my background and the kind of extremities basically that I've also faced also in different kinds of cities. Let's say this, of course, Mumbai, which is, and extremes actually means different things here. In this case, it's again like the mega difference between the rich and the poor. Homes on the other end that we can't even think actually of affording. I had a house in Europe, but I still couldn't think of buying a house in Mumbai. It was that expensive, as opposed to the massive chawls and the massive shanty towns that you see, which coexist still in harmony, by the way. Again, I lived a long time in London as well, which is again a city of extremes that now is actually becoming more evident than ever, of course with the generational difference and the whole Brexit sort of dialogues that are happening now. But at the same time, a city of maximum sort of interventions, maximum kind of developments, and a cultural capital which never sleeps actually. So I was very fascinated with the rhythm of London. After which actually now I lived almost 11 years in Holland again. This whole idea of actually, again, a city of extremes, the whole city, of course, below sea level, still trying to understand how the entire system of water flows, mobility patterns, it's a very different field. So 3 different kinds of exposures, which then led me to sort of believe, after all my years of experimentations with technology, with people, with space, now maybe it's time to start understanding the city as a laboratory itself, and therefore start jumping into understanding the city as a living lab in its own right. And I think this is something which has now become almost like a driver in almost everything I do. So I'm currently also with UTS doing a lot of experimentations with the transport people. I'm working with the health sector. So there are multiple sectors basically that I'm touching upon. But let's try to understand a little bit about, maybe this is a little bit boring, but it's still like in your face kind of information, which is really important to understand the current global context itself. And of course this whole idea, 55% basically, which is the current scenario, global population which is living this way. But then again, to 2050, what happens? I mean, this number is going to be expanding, and it's like 68% of us trying to live together. Well, the desires, aspirations, of course, 1 million weekly making this transition from rural to urban. And of course, it's very apparent also where these kinds of developments are actually happening. And also, like if you look at the Oceania region, 68% of the urbanization. And it's very evident also with some of the things which Rob was talking about, with the third city also sprouting up now. So there are many such things which are actually constantly trying to, so I constantly question myself in terms of when we build, how responsibly do we build. And of course this entire dialogue of actually trying to separate, sometimes it's very apparent actually in conferences as well, this whole difference between, well, we are more people-centric, we are more technology-centric, we are more so and so. Well, actually maybe that's not the case. Maybe technologists also want to look at ways in which we can improve livability, we can improve sort of ways of living. It's understanding human behavior, human movement, through which we can, through technology, which is also giving us feedback of our own behavioral patterns as well. Well, some more statistics, 1950, 2 megacities, today 30, 2030, 43. Trend doesn't seem to stop. Interestingly enough, if you look at what it means, basically, of course, we do generate 75% of GDP, also consume 75% of the energy, produce 80% of the greenhouse gases, resulting in, of course, devastating climate change phenomena, additional deaths which are caused because of various sort of building products related as well as infrastructure development related sort of entities, which again result in additional costs to mitigate these things. Pollution, of course, is unimaginable in terms of the kind of chaos it's actually creating. Plastic in itself, I mean, thank God in Australia now they've started banning things. So but to be honest, like I was used to the Dutch habit, so I still carry my bag everywhere I go. So some things are good. Plastics, well, 13 billion of damage to marine ecosystem, 8 to 10 million metric tons of plastic enters our ocean, and amazingly, more plastic than fish. It's congestion, again, like this is something maybe like Sydney Bells. I mean, I recently started driving here because I had a specific heart condition because of which I cannot take too much stress now. But the moment now I start getting on the roads, I start realizing the perils basically of driving here and what it means to actually be well connected, infrastructurally sort of well knit, which is also the difference I sort of traced between Mumbai, Netherlands, London as well. 80% of urban residents are exposed to air pollution levels, which are, well, Delhi is an extreme example, of course. You've also seen that. Droughts happening, 70% global population, at least 1 month of water scarcity. Europe is still actually relatively harmed by this. Flood levels, again. Well, I don't know. I mean, I can go on and on. It's like sometimes it's a little bit stressful to actually think about the city that we sort of live in and the cities that we actually have come to love actually being steeped into so many issues. Yeah, 46 to the forests that are being cut, actually total amount burned, biomass basically burned. So it's basically it's incomprehensible. Mobility, and actually this keeps on increasing and increasing and increasing. Even now, let's say, I mean, even now, even in Sydney, actually, this whole, there are actually different ideas that are going through, the 15-minute city, the 20-minute city, but the reality basically which comes out of data sets is like it's 50 to 90 minutes average traveling time. Yeah, and including, and there are reasons for this. There are also reasons because of how siloed thinking is actually happening right now in terms of economic centers versus, let's say, affordability issues versus infrastructure connectivity issues. There are multiple things which actually are connected. Affordability, of course, being a mega reason around this. And Sydney, as you can see with the red dot there, is also one of the big, very, very expensive real estate actually. And affordability rates even for youngsters who are actually now trying to settle in this particular town is also becoming a very, very big issue. Livability and its indicators. Surprisingly, this slide, which is again connected with UN sort of statistics, it says that livability is decreasing in most of Western and developed nations. Melbourne, of course, slipped down the ladder this time, but yeah, this is again something which is connected, I think, intricately with the issues of urban health as well, and it's also the amount of stress that actually citizens are actually facing now. again connected, let's say the top 10 reasons of deaths which actually happened worldwide in 2015 are somehow or the other connected with the built environment and the way urban planning actually operates. So globally, there are multiple issues, and then within this context, we try to understand, well, what is so smart about the city? I mean, actually, what is a smart city in the first place? So then we try to sort of look into different definitions of the operative terms themselves, trying to understand what smart actually means, what livability actually means. And the definitions now in black are the ones which I'm actually more sort of interested in. So let's say smart, which is having properties that can be changed in response to stimuli, environmental conditions, self-regulation. Because these are terms which I somehow associate with the idea of, let's say, bidirectionality of communication, the idea of change in real-time interaction, etc. These are things that I sort of grew up with. Livability, let's say, some of the factors that add up to a community's quality of life, including the built, natural environment, so on. So there are multiplicities, and there are livability indexes and how they're calculated, etc. Everything is actually constantly morphing. And then we come to the idea of the city. Well, of course, city with its varied definitions, but I think this whole idea of community or citizenship or community is something which really strikes me, actually, that and this community, I think we cannot simply look at in terms of saying it's about humans and how we agglomerate or we conglomerate. Basically, it's more to do with our relationship with everything else that actually surrounds us and how we live in harmony with them. And therefore, smart city definitions, maybe they are numerous, but at the same time, I would say this one was something which then came closer to what I think is really interesting. So the concept itself is not static. There is no absolute definition of a smart city, no endpoint, but rather it is a process or series of steps by which cities become more livable and resilient, and hence is able to respond more quickly to new challenges. So no matter what you say, I mean, livability, resilience, sustainability, all these factors sort of come together and ingrain themselves in this thinking about the smart city itself. Typically, you find two different trends, of course. One which is the urban operating system based approach, which is again like a very top-down sort of a governed centric approach, which you can see, of course, with almost all the smart city centers that have been set up abroad. I can show you multiple examples of these. And the issues basically, so how do we actually make sure that the kind of data sets that we're using now are safe, secure, they are private, they're not hackable, human rights, are we violating them or not, multiple issues around them. But still, developments, of course, are happening. Bandung, Rio de Janeiro, Bhopal, Glasgow. You can see multiple of these data. The issue here is, of course, how are we responsibly handling data, and actually how are we responding back to human necessities through these technologies. So this becomes a big question where we're actually again looking at, are we sort of bypassing human ethics? Are we actually still being responsible and sort of developing hand in hand? You know, it's a big issue. The second trend, of course, is the other one, which is now spinning out of this kind of let's say this methodology. Now, in this case, we're looking at self-organizing systems themselves. Now here, even though and I'll show you like typical examples of both of these, which also I've sort of delved into. And therefore, I've ended up also with typical questions that I have with them. But in this case, we're again giving power to the citizen. We're trying to understand through citizens. Let's say, for instance, let's say noise tracking attributes. Everybody can track noise with their mobile devices everywhere in the city. They can give feedback, real-time connection. We can understand what is the urban parameters of noise within the city itself. But again, issues here. So the scalability of what we actually adhere to. Is it equitable itself? I mean, does everybody have access to these technologies, etc.? So these are again issues. And then here, there's a different array actually of technology which is at operation. So we're looking at basically right from mobile devices, mobile applications that are like spanning up now. Interestingly, like let's say a city like Bandung, what was also interesting, I was recently there and I was talking to one of the mayors there. Interestingly, he said that there's also an element of fear which also resides in Indonesia. And this element, which is a very real human fear, basically, it's like the guy on top receiving a red light of all the districts where actually a problem has been reported. He knows directly who is responsible to solve this particular problem. Let's say the corporate guy who would be solving this. If that red light doesn't turn to green within 2 weeks' time, his job is in danger. So therefore, there is this technological layer which is actually enabling things to happen, while there's another layer which is a layer of fear, which is somehow still sort of governing this. interesting combination as opposed to other bits, let's say like softwares like Neighborly, which are again looking at neighborhood-based data scales and trying to understand what is the pulse of the neighborhood in terms of the social activity patterns that happen in there. And then we come to the three characteristics, basically. We're again looking at the characteristics, basically. And there are different models now, of course, operating within the smart city itself. So let's say this particular model will still looks at basically the different sectorial kind of development in the city, and therefore works still in a very sectorial and very segmented kind of a fashion, as opposed to understanding how can we club things together, understanding infrastructural needs at a physical level, at a social level, institutional level, and an economic level. And therefore, like even if you look at the subsets of what happens in there, they're also very sort of there are multiple. There's a level of plurality basically. So even if I look at inclusive planning, if I look at entertainment, etc., that becomes a separate division altogether. So now the issue actually comes about is whether we're looking at technocentric views. Are we not people-centric enough? And then how do we co-create smart solutions that adapt to different contexts? I mean, these are questions that are coming down. What about inclusivity? Are we inclusive enough? Do we consider all sections of society? Are they participatory enough? How do we level up a smart city that provides for every strata of the society? Is it solving all the big problems, basically everything that we mentioned, or do we still keep on actually producing more data and more data and more data, but do nothing absolutely with it? What about human rights? Do we ensure that smart solutions are based on ethics, non-discrimination? And again, siloed thinking. How do we ensure sharing and collaboration between different stakeholders? Is that a reality? Because let's say 1.5 years of me being here and me talking with almost all possible government sort of institutions, as well as maybe some mega industrial sectors, I can still figure out that actually how siloed thinking does operate and still takes precedent over this idea of collaborative sort of data sharing and development. But also what is really troubling is whether we are collecting more and more and more. And are we actually getting back to a point where we ever think about real-time actuation? So there's all these definitions around thinking smart, thinking about the city as a community itself. What does happen there? And therefore we were thinking of another model altogether. So how do we think about the city as a laboratory? And in this case, we think about the city as a smart environment itself, in which case we're talking about the city and its understanding as an ecology. And we're trying to actually link these four different components together. And in doing so, actually, the terms which are on the sidelines, let's say how people and context actually becomes desirable. So desirability becomes an objective term here, which we'll then try to sort of rectify. We'll then try to dissect also via quantitative terms, try to understand this. How context and technology become more valuable or more adaptable as well. How economics and technology actually becomes more viable. And how people and economics actually become more equitable. So there are these bigger issues here, but then in this context, let's say what smart actually would mean. So in this case, we're looking at smart environments. So this is something which I was thinking about and also developing as a research group here within UTS. So the essential idea here is to not think in terms of cities or objects, but actually looking at information flows and associated material formations, because almost everything that we think about is in some way a physical manifestation of information flows. And metabolics that happen within the city itself. And therefore smart would actually acquire a different definition. So it essentially means systems and materials in architecture and urban research and technologies. And basically the underlying criteria of this is basically the scales of operations. We really need to understand this, that unless and until we start thinking in a very interconnected manner, which basically links material, computing, products, objects, buildings, and cities, there is no solution. I mean, we might beat around the bush and start thinking, well, yeah, I can make a material change in a pavement that it solves everything. It's not going to do that. So there has to be some way that filters through and basically start impacting human behavior as well. And maybe like, let's say the tangibility of an object as opposed to data which floats around in the air, maybe there could be a decision that we need to make there as to what is more impactful, what is more productive in our case. And there are multiple ecosystem frameworks that have already been sort of set in place, also being experimented with. And here again, you can understand like the entire established layer of operations. So it's not that easy actually because sometimes it's also very easily sort of, it's just very easily said that, yeah, you deal with technology, no big deal. Well, actually it is quite a big deal because we're already battling with all of these issues. and still trying to come up with models which say what is a city-created service, what is a community-created service, etc. While every one of this actually still requires a participatory framework which runs behind it in order to gather information, gather data. Well, of course, it is lucrative for almost all corporates, all institutions. You can look at just the billions of dollars of figures which go around almost every one of these. So yeah, there is massive amount of interests by almost everybody in there. But again, what is happening is this. Yeah, are we looking at diverse sectorial knowledge? We really need to acknowledge this actually. Well, yes, maybe what Andy is talking about in terms of the microgrid creations, etc., is something which is very, very important also for me to be digested in some way and actually plugged into some other sector in here which will actually benefit. So it's not only one thing which actually starts, and therefore the diverse backgrounds, the diverse professions, and this whole siloed thinking approach actually need to be transitioned. So we need to start looking at, leave big data aside, start thinking about linked data actually. And how do we link big data which can actually create an ecology in its own right? How do we start working with multiple stakeholders? How do we work with multiple variable data resolutions? There is so much actually that needs to be done. Even in basic, let's say 3 parameters that can be connected, what can we actually come out of this? And I'll show you now examples of certain things around this. Essentially what we were always looking at, actually even in Delft and even now here, is the connection between this material and the digital. And how these actually, the structural hard components and the informational soft components actually start interrelating, intercommunicating. So physical prototypes, digital worlds, and actually we need to start prototyping more, a lot more actually. That is something, the feeling that I get here. So I'll talk about some projects that actually have been, I'm initiating now here. Let's say at UTS already we are laying the foundation. So the Vice Chancellor actually had contacted us, and now I'm responsible for actually developing an entire Smart Cities postgraduate master's program here, which is again a big collaboration between different faculties which exist here but never share their knowledge. Let's say what does design, architecture and building have to do actually with business school? What does it have to do with the urban health, urban geography? So I'm trying to actually link these partners together, but more importantly, it's the industrial sort of players who are very, very keen now in joining in. The interesting thing to actually understand here is that in academia, sometimes we always say that, yeah, we know what's best, what's coming. It's great, we can actually train every individual. But actually the industry has very different outlooks. And this actually, understand, it's put straight to your face. Like in our case, it was very clear. The industry said, well, I'm not getting people who are prepared and ready to be operational. I spend more money training them than what is your job actually to be training them. And then in this case, we said, well, let's not play the blame game. Why not actually co-develop these things together? So it's amazing, like Microsoft, IBM, Lend-Lease, all of these people joining hands together and saying, yeah, we will co-develop the agenda. So I think it's just a matter of actually taking the first step and actually trying to get things running. So now I'll look at a couple of examples which actually have been done, let's say. So let's start with the data-driven design, let's say. And we're looking at smart interfaces in this case, also trying to understand the city as a multi-dimensional relational system in its own right. So now I'll start with an example of what I did when I was in Delft as well, like one of my PhDs, Achilles, we were actually working very closely together to formulate, let's say, it is a kind of a social platform. It's called Social Glass, in fact. And you will understand, let's say, how heterogeneity of data is now being handled in this particular case. So this is a small video which I think is self-explanatory. So maybe you should go through this.
At this moment, more than 50% of the population is living in cities, and by 2050, it will be 70%. A quickly growing urban population poses challenges that might affect quality of life in urban environments. Such challenges affect everyday activities, but can emerge more strikingly during special events like King's Day or the Amsterdam Light Festival. Providing more sustainable and comfortable urban environments is a main goal of policymakers and administrators today. To achieve this goal, we must first understand the dynamics of cities and their inhabitants. To this end, social data are becoming an increasingly important source of information. Downtown Amsterdam, a busy day as usual. Pedestrians, cyclists, cars, buses, and trams have to share the streets. Thanks to state-of-the-art technology, they all produce vast amounts of heterogeneous social data, mainly related to everyday activities and interactions. Social data are produced in various forms and for diverse purposes. Traffic monitoring and control, environmental monitoring, personal interaction, and open data from the municipality. Each source reflects a specific aspect of the urban environment and is characterized by its scale, speed, cost of acquisition, and most importantly, semantics. Due to complexity and diversity, urban planners and decision makers tend to approach each data source individually based on the problem at hand. This can often result in a biased and incomplete image of a specific urban situation. What if we could fully and systematically harness the combined potential of these diverse social data sources for the benefit of current and future cities? Take, for example, a city-scale event like the Amsterdam Light Festival, where numerous artworks are scattered throughout the city, displayed in public spaces. The festival has many stakeholders. Organizers are interested in monitoring and assessing the success of the event. Visitors want to experience artworks at their best. Residents appreciate visitors, but don't want to be affected by any changes caused by the festival. Social Glass is an ongoing effort to provide a framework that enhances our ability to understand cities through social data. Social Glass provides new methods and tools to create, integrate, analyze, and valorize social data sources in urban contexts. Data science and big data processing techniques are used to analyze massive streams of sensor and social media data. Crowdsourcing and human computation enable interpretation of ambiguous or hard-to-analyze content. And semantic analysis and integration link them all together, providing a holistic view of the studied phenomenon. Thanks to Social Glass, each stakeholder has a clearer image of the city, enabling them to map city sentiments, locate bottlenecks, and define potential solutions to improve the quality of life. Social Glass. It can be used in a variety of applications in urban analytics and planning, including the reconfiguration of public spaces, environmental monitoring, and transportation infrastructure rearrangement. Thanks to the power of human-generated data, Social Glass can provide you and decision makers with meaningful insights about the dynamics of your city.
So interestingly, like here as well, the idea was not only to actually work with the prowess of big data and how processing tools and algorithms can actually work, but actually it was more interesting to how to harvest human-produced data itself. And so this whole concept of people as sensors themselves actually became something which was very intriguing to us. So social media-based data, of course, become a very big positive. But at the same time, this whole idea of how is the system open enough so that you can keep on adding actually more attributes, more sensing systems, more ways of capturing data sets actually became really interesting, till the point that we actually also went to a level where, let's say for instance, simple incidences like these, where actually people themselves are actually simply entering their postcodes to say actually where crime rates are actually occurring more, which actually becomes an active source of populating this data. And then you actually visualize this data in front of them and then start relating it with parameters, saying, was it dark, was it not dark, is it too congested, is it not congested? And then you can relate these and project these in front of them. So this whole idea of actually visually connecting with people is something which is really critical. Now there's another tool here called Neighborlytics. Actually, this is something which is again driving basically through social data analysis, and it's operating at a neighborhood scale. This is another very interesting proposition here, which is actually now looking at precincts rather than big cities, and therefore trying to actually judge and gauge, let's say, the pulse of neighborhoods itself. So we're looking also at place diagnostics, we're looking at social activity patterns, which particular areas in the neighborhood are actually more active, which are not, where actually development needs to happen, where things need to be patched up, etc. Another thing, let's look into smart computing methodologies. I think this is something which is also very intriguing. Like we were working a lot with the design-driven sort of simulation methodologies. In this case, we're looking at multi-agent systems. But again, trying to understand, let's say, even in this case, if you were to segment a piece of land, let's say every 5 square meter, and each 5 square meter is actually producing data in relation to noise levels, in relation to solar exposure levels, in relation to the amount of people actually passing through it. This actually can result in the spatial agglomeration, basically, of what kind of programs is actually afforded by that particular site. So this idea of affordability and affordance, let's say at a spatial level, is actually what is being self-organized here. And while it is actually doing so, it is also calculating the amount of solar exposure that that particular program needs in real time. So we're looking at multiple kind of solutions that can be processed through one set of algorithms, which actually results in different kinds of, let's say, spatial qualities, different kinds of spatial attributes, how space can actually be combined together. And at the same time, actually, this whole idea of parametrically developing design systems which can become energy efficient in their own right. So the idea of how to reduce, let's say, the amount of cooling or heating required because of the way spatial elements can actually be positioned and generated in real time by tracking, let's say, the amount of wind it can capture or by tracking the amount of sun it can capture. So it was like a holistic system which in its own right is actually developing space in real time. As opposed to another stage, in this case, it's a precinct level scale, basically. We're looking, again, now this is a different level where we're looking at plot division, which is again based with this idea of the gentrification, basically, of people that will be living there. How would they like to share their plots? In this case, now what it's doing is basically the calculation of the closest or the best possible pathways for people to actually traverse through, and therefore generating an entirely organic but a formative infrastructure system through which we can actually start defining space and its subdivisions itself. Now what's interesting here is like the moment now you start diving deeper into these, so let's say now I look at an infrastructure, it's an intersection infrastructure in this case. And actually the different strands and the different colors are now also representing the different density of people flow that will actually happen through these particular pathways. Because now I know the overall structure which actually has been defined because of the computational method. And through these actually then we start thinking about what kind of program, the kind of area, the kind of volume, etc. that is actually required for these programs to be stitched together. And therefore the entirety in terms of the development of not only, let's say, the woven infrastructure bit, which is performative in a sense, but at the same time, the kind of place-making attributes which will now start being put in place. As opposed to, let's say, from this scale, we can also jump to another scale, which is then connected. In this case, it's like a city scale place. And this was a very interesting project that we also did for Almere, actually. And interestingly, like we were looking at, let's say, this agglomeration that you see here is basically the introduction of a new bridge system that will actually span the river. And actually it's going to bring in a lot of people in there because of a new airport node that was also going to be sort of located there. Now the idea was to think about what is going to be the impact or the influx of population within this particular area. If so, what is going to be the kind of, let's say, the level of income and therefore the kind of housing typologies that are actually needed. And what could be the possible density as well as the pattern within which these things can actually be arranged here. So all of these things are also calculated in real time actually, and the idea of actually thinking not only in terms of respecting government regulations, but at the same time coming up with solution sets which are actually giving you variety in terms of what to choose from, but at the same time literally pointing out what are the pros and cons of actually each one of them. And therefore, what could be high density, what could be low density, what should be the maximum heights, etc. They were all calculated together. We move to another project. In this case, again, this is another methodology which is again connected with the generation of a. Again, it's a multi-agent system, but it's more about infrastructural development this time. But in this case, the idea was not only to think about infrastructure for the sake of infrastructure, but infrastructure which populates program within its structure. And so that was again like a very big sort of a stake in this. And in this case, actually, what was also interesting enough was actually when the routes are actually being calculated, that were actually being calculated by a predictive engine that was running behind it, which is actually, I'll just show you, it's like this engine, which is calculating the maximum probability of people actually moving from one direction to the other and crossing through the city itself. And therefore, the catchment area of these people as opposed to the maximum density of flow of these people. This actually results in very, very interesting solutions. Let's say first, also in terms of safety and security, in terms of how transitioning of different infrastructural elements can actually happen, what should overlap, what should connect, how much interactions actually should happen, to actually creating infrastructure nodes which are essentially they look complex but are extremely performative. And almost, I think it's also interesting, almost all our fluid interactions are actually very, very non-geometric. Actually, they are literally fluid. And this whole idea of actually coming up with how space, infrastructure, and productivity, let's say, of that particular patch of land can actually be enhanced together in a performative manner is something that can literally be actually dealt with together. Let's look at some other examples as well. So we were looking at some socio-technical urban interventions as well. Now, in this case, again, it's also people-driven. So the idea of, let's say, coming up with a system. So in this case, we are again looking at an urban open square, and we were thinking about what happens if robotics was actually put to a very different use. Let's say, for instance, it's a gathered sort of stack of cubes, which is now being fed in by social data. Yeah? So I'm programming and I'm saying, well, I'm coming with my 2 kids. I would like to have a pod which can have so and so. I would like the kids to play so and so. Now the pod is actually customized for me. It receives this data, it takes it out, self-organizes, rearranges, and therefore produces a different definition of how urban space can actually be used and utilized in real time, and therefore how usability patterns can actually change constantly. What you see on top is actually also like the whole idea of how, so it's not just an idea, it's actually how it can be created. The whole structural system of it, how does it work, what role would engineering actually play, etc. As opposed to these kinds of experiments, which again, we were looking at pop-up apartment systems as well. This was a very interesting project actually, which we also did in Delft. In fact, it was a fantastic project in which there was this, the economic crisis, and there the developers came to us and said, well, we want to use the same footprint that can actually be the footprint of a 1-bedroom house, but we want to have the luxury of a massive apartment. What can we do? And then we said, okay, let's start playing actually with the interior configurations, and how can we make that flexible enough? And therefore, and almost everything that you see, whatever I'm showing, is always has a physical counterpart. It's never like it's never left at the level that it's an idea. The same thing here. Let's say we were now in this case we're experimenting with 2 different things. There's a soft robotics thing, and there's a social robot idea. And I'll talk to you about both. So let's say the first one that you see there is connected with an actual platform which can actually be spanned across the river. In this case, again, like my movement as a human, and let's say my gathering quality of what I want from the space can actually be programmed. And therefore, inflatable systems, which can actually change in real time, are basically responsible for accommodating my wishes within that particular space. And these spaces can also work as follies. They can also actually join together, help for crossing, etc. They can do multiple things, while of course measuring multiple, let's say, water-based qualities as well. The one below actually is another experiment, which was a social robotics experiment. This was also done for a European Union project actually. Interestingly, the idea there was to work with non-verbal communication. So the idea, if you cut down all the chatter and if you work with, it's not even data. It's just pure tangibility of an object and basically the expressivity of this object and how it can communicate with you. And the main ideas behind this was to actually think about proactive behavior. So how can I, rather than telling you to get up and actually do a particular job, actually just works with the expressiveness of this object. If it is stuck, I come and actually pick it up. I want to start playing with it. I want to start connecting with it, etc. So there were different levels, and interestingly, like just before I left Delft, Amsterdam University actually connected with me, and they were talking about activating urban open spaces and actually also reduction of crime and how can we work with that. In this context in Sydney, actually, I've already made some propositions to the defense people here, and also thinking about post-traumatic stress disorder and how can we reduce that and reduce social isolation with such entities. So there are multiple things actually that are happening with data at different scales, which actually need to be interrelated. The last one, actually, smart materialization strategies. Again, in this case, we're looking at how do we combine robotic systems together with any facade development project as well. Let's say in this case, we were working with like a real-time data capturing system, which is looking at wind speed, wind intensity, and trying to push actually wind inwards, which is actually then powering wind turbines in order to generate LEDs that will power that whole front scheme. And the whole system was actually also prototyped, it was tested, etc. As opposed to these, when we were looking at multi-performativity itself and trying to understand, let's say, for instance, right now the issue is also this, let's say, how we treat material, how do we deal with material is also another very big issue. And remember, I mean, I'm still spanning this whole multi-scalar sort of attributes. So in this case, we were thinking of, let's say, if you work, just forget the form, it's not about the form as such, but it's about the performance quality of this. We're trying to understand how do we make, let's say, a material like cork, which is more malleable, in a way that it actually reflects sound where it needs to, but at the same time absorbs sound where it actually needs to. Yeah, so in this case, we were looking at, this is just one of the strips actually that was created, and this whole idea of working with, let's say, with a high density foam, which is then integrated and sort of imprinted with the cork. And this was actually, of course, again, manufactured, as I said, and we were testing basically. Also, the pattern is important to understand how the pattern and the flexibility without it actually breaking can actually work for us. And therefore, precision-oriented sort of construction became a very interesting element. But I mean, let's say to enable all of this, we still need collaboration, we still need co-creation, and that's where basically the quadruple helix model sort of comes in. That's something I learned from Rob when we were discussing constantly this idea of how collaborations can actually take place. And what I realized actually now is that more than ever, in fact, it's like it's not just enough for us to be in our fancy labs and actually start developing things, but actually to really go out in the market and understand the value which different stakeholders seek from the same product. And so the idea of working with business, with government, with academia, and with community, more importantly, I think is, and to work with community, I mean, so whatever I showed you today, it's not like, yeah, mobile phones are the only best way to collect data. Well, no. Now we're working with different kinds of projects in which, let's say we are working with Transport for New South Wales for the autonomous vehicle projects, very recently. Interestingly, like, what would be the best way to capture this data, and how do we make surveys also in a way which can also be parameterized? You can actually seek this information back, and then start to explore this information in a way that can actually give feedback to the manufacturer of the shuttle, which can give feedback to the roads and maritime services, etc. So we are trying to actually work in different ways, in which even qualitative information and quantitative information can actually be fused together. So very recently I worked on a big paper on well-being as well, and there the big finding was that it's not just important to measure well-being from a quantitative and a qualitative point of view, but maybe there should be a citizen science-based layer which is inserted in between, which acts as basically, it's a validation sort of a perspective of understanding these data sets together. So I think, yeah, I think it's enough from my side. I mean, I have more questions. Actually, every time I give a lecture, I have more questions for myself rather than actually seeking out answers. But I think I will basically, I really wish to think of ways in which, yeah, maybe we can transition from this to this. But also at the same time, when I question myself, and it's always like, is there something which is like this bigger philosophical questions around identity, which actually, I don't know, what differentiates a city, what really makes its character, and therefore, is this good, is this bad? I don't know, like, I think it's for all of us to decide. It's also, basically, it's the power of the people which should actually start deciphering and deciding upon things. So, yeah, I will leave you with that, and I hope, it's 6:30 exactly, so I think it's it's good. So thanks a lot, and sorry to bother you and be between you and your dinner. So
Well, smart enough for you. I think so. Do you have an answer or a question? I think that you didn't give an answer now, because
Just have a question.
Yeah.
It seems that half of every second paper or presentation about cities starts with this statement that 50% of people live in cities, and by 2050 it'll be 70%, and it's presented as a fact and an inevitability, and then a justification for everything else that follows after that. How do you reconcile that with the other statement that of all the images of environmental collapse, which will imply food systems collapse? And where do you see that growth coming from if those food systems, and there's no people producing that food to support that growth in population?
yeah, that is a mega question, definitely. I mean, so for instance, I'll tell you about two different projects. Like, I'm now dealing with an algae-texture project actually. We're looking at biomass basically, and its production as well. But at the same time, we're trying to understand, let's say, how to, that's where I'm talking about, let's say, talking about different parameters and its connection together. So urban heat mitigation, but at the same time, let's say, for instance, in this case, in Sydney itself, we're looking at shading and basically cooling down the temperature itself. So we're also looking at these two attributes and thinking about urban agriculture possibilities here. But then you actually strike a different note, because then you talk about the production levels versus the actual sustenance and the maintenance that is required, the cost basically factors in there, which again don't add up. So yes, there are multiple questions. I mean, I really don't have answers basically for all of this, unless and until we go to the Neri Oxman way and start developing tools which can actually beat out and things like that, which is actually, I don't know, that's very utopian. But I think that there needs to be a way in which more responsible land distribution, more responsible, let's say, integrated development, which does take care of these, rather than us looking at these entities. It's almost like post research, sort of. This is a very common thing I've seen here somehow. Like everything is about post analysis, and then we start understanding, this is a problem, that is a problem, and then I somehow still don't see solutions or even new things that are being built actually being informed by these strategies as to what went wrong, and therefore how do we. So yeah, I don't have an answer basically for you. I'm still in the same quest actually. But what I'm saying is maybe when we design now, even like what Andy Rios suggested, I think it is really time for us to be extremely responsible in terms of even from this very basic fact of what does a wall actually mean in today's context. It's not just a wall anymore. So, and it's surprising, let's say the most ugliest building in the whole UTS campus, which is that tower, to be very honest, is the most coolest in the whole summer. And it's still just a statement which still actually says that and I'm not saying that aesthetics is a reason which sort of overrides everything. I'm saying there is ways in which we can actually design more responsibly. There are ways in which computational tools and techniques can be harnessed to actually become more performant. But it's just a matter of actually thinking about this together.
I think that's fantastic. Just thinking about this together. That's maybe the most important thing of all would be find solutions that on our own fields and islands that we work together on. Thank you very much, Nimi. It was great to listen to you and fantastic.